Hey Mohawk Nation, we're going to do another mass-to-mass stoichiometry problem. This time it's going to be from practice sheet number 7 and problem number 1. So let's go ahead and read it. Although mixtures of hydrogen and oxygen are highly explosive, pure elemental hydrogen itself burns quietly in air with a pale blue flame, producing water vapor. Write the skeleton equation, then balance it for the above chemical reaction. Remember that things that burn need oxygen. So we're going to go ahead and we start off with what we have. We have hydrogen and oxygen, okay? And they're going to produce water vapor. So we're just going to go ahead and write down our hydrogen plus our oxygen, and then that's going to yield water, H. Oops. Okay, so there are two things. But before we can actually finish the skeleton equation, as always, we need to make sure that we have everything the way that it needs to be. And we're just going to take that off there. So we always ask this question anytime that we see an element by itself. Is that element diatomic? And let's go ahead and look at our periodic table. And we see that hydrogen is right here and oxygen is right here. Now, our diatomic elements are these 7 right here, so oxygen is included, but it also includes hydrogen. So it's these 6 that make a 7 and hydrogen. So let's go back to the original problem. So we know that hydrogen itself is diatomic, and so is oxygen. So now we have to go ahead and balance it. And again, my suggestion is make sure that we have all of our elements that we have on each side. Okay, and we have hydrogen and oxygen. So I'm going to go ahead and put on this side, I have 2 hydrogen. On the other side, I have 2 hydrogen. On this side, we have 2 oxygen. And then on the product side, we have only 1 oxygen. So the thing that we're going to start off first is oxygen. So I have to make a 2. Now remember, only thing that we can change is our coefficients. We cannot change the subscript, so I cannot just put a subscript 2 here. So remember that these are multiples, and we can even say that they're moles. So we're going to put 2 right there. So that means we have 2 of everything after it. So that means I have oxygen once with a subscript, but I'm going to multiply by 2. So that's going to change to a 2. Okay. But it also changes our hydrogen. So I have hydrogen, I have 2 hydrogen, but 2 times, so that changes that to a 4. So then we get rid of this. Okay, and so now I have to chase it over to the other side. Now I need 4 hydrogen on the reactant side. And again, the only way they can change that is with a coefficient. So what times 2, since I already have 2, what times 2 equals 4 is 2. So that means that that changes that to a 4. And we have everything balanced. So my molar ratio is going to be 2. And we're going to put a 1 in there. Okay, 2 to 1. To 2. And really what that means is that if I have 2 moles of hydrogen gas, I only need 1 mole of oxygen gas to produce 2 moles of water. So that's very important for you to understand that those are equal to each other. Okay, so now we're going to go down and we're going to look at our molar masses. And in order to do that, we have to look at our stoichiometry a little bit. Okay, because our stoichiometry tells us what we have to, how do we have to calculate our molar masses. So and this part of the stoichiometry says, after you have balanced the above chemical equation, calculate the mass in grams of water. So we know that we're going to need water, the molar mass of water. And then we also say that we start off with 56 grams of pure hydrogen gas. So we're going to start off with hydrogen. So we're going to write down hydrogen. So I have hydrogen gas. Now all the gas means is that it's in that state. Just like when it says water vapor, if I tab over and I do water vapor, it's still just water. So I'm going to come down here and I'll put in, I have hydrogen in this one, and I have one hydrogen times, excuse me, I have two hydrogens times its molar mass. Now, what is the molar mass of hydrogen gas? Well, if I go to my periodic table, I see hydrogen. I notice I have two ones in it, while the larger number in the box, in this case, they're both the same, they're both one, is our molar mass. So in our periodic table, the one on the bottom is the weight, and we can see it right there. And so we go back to the problem, and we'll multiply 2 times 1, and that's going to equal 2. And that's going to be grams. And what does that equal? That's going to be grams per 1 mole. Now let's go over here to our water. Okay, and so I have hydrogen again, and I have 2 hydrogens times the 1 that we had before, and that's going to equal 2. And then we're going to come over back, and we have water, so we have oxygen, and we only have one of them. See, there's no subscript. If there's no subscript, that means 1. So we have 1. We're going to multiply that by the weight of oxygen. Now the weight of oxygen, again, we got to calculate it. So let's go to oxygen. Here's oxygen right here. And we see that there's 2 numbers, 8 and 16. 16 is the weight. So we're going to change that to grams. So we'll go back and we'll put down 16. And that's going to equal 16. And then we have to tally them up. Well, this one up here only has one element, so there's our tally for that one. So we're going to put this right there. We're going to highlight that in yellow. And then I'm going to come down here and put in my total for this is going to be 16 plus, if we move this over just a little bit, 16 plus 2 is going to be 18, and that's going to be grams, okay, per 1 mole, and that's going to be H2, and I keep doing that occasionally, H2O. Okay. Now we're going to need this number, okay, and the other number that's highlighted in yellow in our stoichiometry. So let's go ahead and start out with stoichiometry. And as you you should recall, when we start stoichiometry, we go back to our problem and we say, what is the number in our problem? In this case, we have 56 grams of pure hydrogen gas. So that's what we're going to start off with. So we're going to start off with 56 grams of pure hydrogen gas. And we don't know why that's highlighted, but okay. And then what we're going to do is we're going to multiply that and divide it by a fraction. Now that fraction is going to be equal to 1, and that's going to be our molar ratio. Okay, and so I always like to say, well, let's go about what's on bottom. So we're going to go ahead and we're going to put what's on bottom first. Well, what's on bottom first? We have to get rid of the grams of hydrogen gas. So we're going to put down grams of hydrogen gas. Now that gram is going to be this up here. So we're going to put a 2 here. And we'll change this back to a lowercase. And on top, that's equal to what? Well, it's equal to 1 mole. So we're going to put 1 mole of hydrogen gas. And we got to realize that these have to be equal to each other. Okay. So 2 grams of hydrogen gas equals 1 mole of hydrogen gas. We're going to go ahead and multiply that next by our molar ratios. And before we do that, I'm going to go ahead and underline this real quick. And then on the bottom, we're going to put our molar ratio for hydrogen gas. So we're going to go back up to our problem, and then that's a 2. So we're going to put down 2 moles of hydrogen gas equals what we're looking for. We're looking for water vapor. So it says calculate the mass of grams of water vapor. So we're going to put that on top. And so we're going to look at up here, and we see that, oh, we got 2 moles of water up on top. So we're going to put 2 moles of H2O on top. Tab over, put our next multiplication sign in line, and we're going to underline this. Okay. Now once we get with this one, now we got to convert back from moles of water to moles or grams of water. So far, I can get rid of this, and this because it's the same on top and bottom. I can get rid of this and this one. Now that shows us that we're left with moles of water. But I got to get rid of moles of water and change it to grams. And the way that I'm going to do that is going to through the molar mass conversions. I'm going to use this one this time. But we're going to do just the opposite because I have moles of water on top, so I have to put moles of water on bottom. So this 18 grams equals 1 mole. So we're going to put 1 mole of H2O on bottom, and then on top we're going to put our 18 grams of H2O. And then we're going to have our equal sign. We're going to go ahead real quickly and underline this. And now I'm going to get rid of everything else. So I have moles of water here and moles of water here. So we're going to go ahead and get rid of those. Okay, and I've got rid of all my units because remember, if there's a unit left, it needs to be in your answer, but we need to get rid of everything that we can. So we're left with grams of water. And let's go back up to the question. It says, after you have balanced the above chemical equation, calculate the mass in grams of water vapor. Well, that's what it's asking for. So we know that our answer is going to be in grams, okay, of water vapor. Okay, but we have to calculate that out. So we're going to go ahead and do the math. So I'm going to quickly pull up our calculator. Okay. Okay, let's get that over here. And right here it is. And so we're going to go ahead and look at it. And remember, when we do our stoichiometry problems, we're going to multiply by the top and divide by the bottom. Multiply by the top, divide by the bottom. So realistic, what I'm going to do is I'm going to take 56, I'm going to multiply by 1, and then divide by 2. Then I'm going to multiply by 2, then divide by 2. Then I'm going to multiply by 18 and divide by 1, hit my equals, and I end up with 504. So 504. But I always like to double check this, and we know that if I have ones, I don't have to worry about ones, and plus I have a 2 over 2, I don't have to worry about these sets of 2. So we're just going to go 56 divided by 2 times 18, and let's see what that is. Okay, so we're going to have 56 divided by 2 times 18 equals 504. That's pretty good. So let's go ahead and look at our problem to figure out if we have the correct number of significant figures. So we know that we need 3 sig figs. Now, the reason we need 3 sig figs is right here. I have 2 numbers. The numbers are always significant. This 0 is significant only because there's a decimal in the number. I already have 3 significant figures in my answer, so I can go ahead and just highlight that, or just go ahead, I'm going to just copy that, and we're going to paste it right here. And so we know that there's our answer. It's in there, and we're all done with that. Okay, our next step is we're going to do percent yield. Now, percent yield is a formula that actually is our percent, and we'll just call it that, equals. Okay, what it's going to equal is our actual yield, and that's going to be divided by our theoretical yield. Okay, so that's kind of what it is, and we're going to go ahead and well, I'm going to tab over here a little bit. We're going to underline this one right here. Okay, and then that's going to then what we're going to do is we're going to multiply by 100 to get our percent. Okay, and then that's going to equal our answer. Now our answer needs to be in one place after the decimal. Okay, so we're going to round it to one place after the decimal. And so what we're going to do is I'm going to replace this actual yield right here with the number in here. It says actual yield 500 grams. So we're going to, up here, we're going to put 500 grams. And on the bottom, we're going to put our theoretical yield, which is 504 grams. Doesn't really matter. Our grams over here can cross off. Okay. So now we can go ahead and do our math. So we're going to get rid of this. We're going to have 500. We're going to start with 1 on top. Divide that by 504. Okay. Hit equals, and then multiply that by 100 to get our percentage. And so we're going to be at 99.20. 99.20. Let's double check that again. 99.206. And it doesn't really matter if that 6 is there, because we're going to round to one place after the decimal. That means we're going to look at this right here. We can even insert a special characteristic right there. I like to do that most of the time to show that that's where I'm going to round. The 0 says we're going to drop that off. So my answer, and I'm going to put in a percentage here of H2O. And so we're going to come over here and type it in. So we're going to have 99.2% of H2O. Okay, so there's our answer for that. Here's our answer for this. Again, I like to sometimes make that a little bit larger, so we can do that, make it bold. Okay, pop that over there. We're all set. There's our answers. So I have our molar ratios right here, and if I want to put the, or I need to put this up here, I'm going to put 2 to 1 to 2. Okay, and again, I look it through, make sure I have everything that I need, make sure it's balanced, because if I make a mistake up here, I'm going to make a mistake down here. Okay, and then we get to the end and we see what we have. Okay, it looks like we're all correct. So our final answer for percent yield is we made 99.2% of what we should have made, which is actually pretty good in the real world. Hey, as always, go Mohawks. Nelson out.